Okay, so what's up, guys? Today we are going to talk about how to read GRO files in Python. This will be the first part of the Gromacs analysis series. So, without wasting your time, let's get started. So, let me just quickly open the folder where I'm going to work. Okay, so here, as you can see, there's already a GRO file that I've already copied here. So, let me first show you what's inside this file. So as you can see, there are about 12,870 atoms. And then in the beginning, there is a small peptide that you can see that which is somewhere about 26 and going. Okay, yeah. So there are about 26 residues of peptide, which constitute about 400 atoms or so. And then from there's a lipid component which then goes down until about, so there's like a lipid membrane, and on the top there's a small peptide. So basically that's the file, and we are going to read this file from the very beginning, and I will show you how you can actually take all these files into Python. So I've actually went inside a Conda environment where I have Jupyter Labs and stuff. So I'll just open my Jupyter Lab. If you don't have this, you can actually install it. Just go to Google and search how to do that. Okay. So this clicking on that link that you see here, it will open this Jupyter Lab on your browser. Okay, so there's this file that you can see. If we click on it, you should be able to see that file here as well. Okay, that's nice. I'll, I'll create a notebook, and we don't need this. Okay, so first of all, I need to import a couple of stuffs. So for example, I would import NumPy, and I would also import OS. So these are some of the modules that I would require in the later part of the video. So let's start. So first, to read this GRO file, I need to know what is the format of this, storing these files. So first, there's the first line which says, a title of this GRO file, which we can usually skip. There's no important information here except the name of the file. Then we have how many number of atoms we have in this whole GRO file. So this is super important. And then we have a series of atoms, individual atoms, that shows or depicts what the files are. So thirdly, we need to know what is the format of this, so we can actually get an idea. Like this, the first column, which is like a number or an integer, and then there's a text, and then there's a text, and then there's a number. But we would need to exactly know what is the exact string formatting. So for that, we will actually go to Gromacs, and we will write formatting, GRO file, and we'll try to find that. So there's this documentation of Gromacs that says file formats. I think any of these links should be able to give what we are looking for. So yeah, this is exactly what I'm looking for. So it says Fortran format, but all I have to understand it's what is in there. So I'll just copy this format from here, and I'll paste it here for my reference, so that you guys can also um, keep looking into this. So firstly there's integer, and there are about five what do you call it, like these, 1 2 3 4 5. So there's an integer and that takes about 5 spaces. Then there is a text that takes about so there are like two columns for text. Each of these text columns are about 5 width long. So from here I'll start 1 2 3 4 5. So first column, second column is done. Then we'll go 1 2 3 4 5. The second column is done, and then we'll go back and see um, there is about I5. So there's five spaces for an integer. So from here we'll go 1 2 3 4 5. So this column is also done. Now we have three columns which are about 8 width long, and then there's about three spaces for the like decimal number. So from here 1 2 3 4 5 6 7 8. So this eighth column is finished, and then you see there's three spaces for the decimal number. So that's what this part shows, f8.3. And then there are about three, so we haven't finished the three. So first is finished, and then 1 2 3 4 5 6 7 8, and then 1 2 3 4 5 6 7 8. So this part is now finished. So now you actually know what kind of string formatting is has been used in this. So just keep this in mind, because we are going to really rely heavily on this. You might be questioning what happened to this one, this last row, that, sorry, column, that said there are going to be three columns of 8.4 each. So actually this grow file, as you might or might not have, in some grow files you don't have the velocity. So if this grow file would have, have the grow velocities in there, then there would be like three more columns. And in there the widths would be about 8.4. So that part is over. We will now come to how to read that. So we'll first make a definition that says read grow. Let's, this would be fine. And we will put in the file name. So sorry, so I'll put in the file name in there. Now what are the other information too I need? First written, let's just return the file name for this moment. This is a function, it's a useless function that doesn't do anything, but let's just see if this works. So in the file name I'll just provide the file name, which is grow file. So sorry, file.grow. So it should give me so it says file name is not defined. So this was the error. Here I have put in the n in caps, and then here it was not so. So now, yeah, it returns the same file name that we have incorporated. So moving forward, we need to actually go into this file, read this files, line by line. We have to read this file and then extract all these characters from inside. So firstly, for reading this file, you might know we can do it with open, and then here we can put in the file name, right? And then we need to put that we are reading it, and then there's file. Okay, so now I can actually do file dot read line. So what this will do, this command file dot read line, this will actually just read the line once, line by line. So the first line that we would read here is actually this first, which is we can call it the file name or something, or I'll just write first line. So I'll just write first line equal to file dot read line. So this contains the first line, and then to read the second line I have to invoke this part again. So if I run this again, then it will read the second line. So now from here it's an important stuff. The second part is actually, so let me do one thing. I'll just copy it here. Okay, now I think it's much nicer. So as you can see, I can read the second line here. Now the second line is about the number of atoms. So I'll call here num atoms. Okay. So this now contains the num atoms. If I want, I can just return the num atoms, and this should actually give me the number of atoms. So you see, it actually also contains the new line character in there. So to remove that, we can actually put a strip, and inside we can put a new line. Okay, so this should actually remove the new line from there. Also, one thing you might notice is that the format of this num atoms is actually string, but we want to keep it in a number because this is a number. So if I put in type here, if I return the type of this num atoms, then it should give me a string. So as you can see, it gives me a string. So what I have to do is, since I know that the number of atoms will always be integer, I can actually put in an int here at the beginning of this. So I think if we put in an int here, then the type will become integer, and that's exactly what we wanted. So now if I remove the type from here, so as you can see, now you get a number back, which in the first place we wanted. Okay, so far we have read the first line of the file. We have now also read the number of atoms in the GRO file. We need to use this exact number of atoms to go through this you know atom line by line. So why do we need this? Because if you actually see, they're about 12870, and if we go to the end, so it starts from 1 2 3, right? If we go and check the number of atoms at the end, you will see that number again. So I think it's not able to read properly. Okay, it does. Okay, you see here the if you see the number here, it's 12870. So I think that's the number you have seen up there. So this part is over, right? We have to now see uh, how to go from a loop to read this. So let's come back here. So now here we can write for item in um, or let's do one thing. So since we have the range, so we can write, since we have the number of atoms in there, so we can go from num atoms. So for item in range num atoms, um, let's call it I, and then we'll print file dot read line content. So basically what this will do is, I've just started a, a for loop. Well, what this will do is that it will just go, it will like run the for loop for a number of atoms, and what it will do is, at the end of the loop, it will actually like be able to generate or print all the lines line by line. So let's do that thing, and here we should start seeing all the atoms. we have successfully done that. Okay. So the next part is we have to somehow take the content of these read line function, and we have to segregate them individually so that we can store these things separately and not in a like a text file or something. So let's remove the read line from here, and what we'll do is we will create a content equal to a list, and we'll make a list of list. And or what we can do is we can actually store, let's say, let's do it this way, that we will first store the the first column, which is the res id. So we will write res id equal to, there's a list, and okay, there's a better way to do this. We will write the second column is actually the res name, so we'll write res name. The third column is about atom name, so we'll write atom name. Then it's atom id. um, so this one is atom id, this one is atom name. Now it's the position, so x, y, and z. So we'll also write that x comma y comma z. And now we have to count how many elements we have invoked: 1 2 3 4 5 6 7. So we have to now put in 7 lists here. So 3 4 5 6 and 7. So that part is now done. We'll come back here. Okay, great. So we have now created some empty list up there. If you want to see, we should just, yeah. Okay, so we have now able to create all the empty lists that we wanted. And what we will do is inside this for loop, we will just um, start keeping these individual elements inside this specific list that we have created. So how are we going to do that? So the first part would be actually to break these individual things into lists so that we can pick these things up. So the contents first 5 lines. So you remember how we have wrote this. This would be more interesting now. So we will actually let's call this line. Okay, and once the line has been read, we will start adding it to our, okay, append. So we will use this append function. So res id, we're going to append this thing. How are we going to append this? So the first we will take line. Since this is a text element, we can do slicing on this. So to do slicing on it, we will say from 0 to 5. Okay, and we are going to return the res id, and we are going to see if this actually works for at least the res id, and then we will take it forward. So as you see, this was supposed to be like this. It's how we have said 1 2 3 4 5, right? And it have apparently read it well. Okay, this seems good. The second part is actually to read the res name, and we'll do it again similarly. Now the we are going to read from 6th position to how much, 10th, and let's return the res name. And it have, let's see this, set it, okay. So we have made a mistake. This slicing would have been from 5. Yeah, now it looks good. So does it have 5 elements? 3, 4, and 5. So this have 5 elements, and then we have to read the next 5. So the next is, we have read one of these texts. So there's another 5 that we have to read. This would be named as atom name. So you can read it like this: 10 to 15. And after that it's atom ID. Okay, so let's do it one by one. 15. Okay, so we'll again compare it with the first one. So you see it have actually read it quite nicely until the end, so that's fine. And then we should have about 5 spaces to 1, 2, 3, 4, 5, and this should be an integer. So yeah, this I5. Yeah, this looks good. So the next one is atom ID. We'll do this: 15, 20. Okay, after this is X. The same thing. Now it's about storing about 8 numbers. So sorry, 8 spaces. So we will do it from 20 to 28. And by the way, you can also, in the same line, you can execute multiple of these append statements. So for example, I can also do y append. Let's say you put in line, and then you put in 28, 2, and then 29, 30, 31, 32, 33, 34, 35, 36. So you can, go up to 36, and you can, put in another comma and do that. But for you to able to see this, I'll just keep them in a line so that's more visible in a way. So Z append, and here you're going to see from 36 to about 42 or something. No, 44, I guess. Okay, let's check the Z. Yeah, this reads it properly. So until 3988. Okay, yeah, this I've read it properly. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is fine. So we have actually been able to read all the elements properly. One thing that we haven't done so far is, um, let's say now return everything at once. So I'll just copy from here till here. I'll just put it here, and when I return, this should be able to return everything. So one thing to note is, since you have seen that I have returned everything here, the proper way to read it back would be, let's put it this way: A, B, C, D, so that I don't have the same names in there. F, G, H. I'm not sure how many of 3, 3, 8. I think H is not needed. So if I do this, this will also work. That here A will store this res ID, B will store the res name, C will store the atom name. So in a way you have now, let's see, if I print C, this should be able to print the atom names. So this have actually done that. Now there's a thing that you might want to also work with, the coordinates for our next part of the videos. So if you want to work with these coordinates needs to be in the float format and not on the string format that they are currently in. So for example, if I show you the E, you see these are strings actually. If I go to the first element of this E, then this is the one, and then if I put in type, this should stay string. So we don't want that. So we want them to be, actually, like float numbers. So what we can do is, for that, is either we can later convert them into something like, e equal to np dot, so how do you call it, array. Oops. So here you can actually put in like this, and try, if you print this. Okay, there's still numbers. So there's, I think there's this function called dtype that you can provide float, maybe 64 or 32. Let's put 32, and now it should be able to do this. Yes. So now see, now these elements are actually being converted into float numbers. So if I do that thing again which we have done there, like the first element, okay, now it already says it's a numpy float 32, but we will still do it, type, and you see it says float 32 numbers. So we can now work with it. The other way would be to, while you're appending these lines, these three lines, you actually, just put in a float here. Like if you put a float here like this will also, like the Python will also convert these numbers initially from the string format to a float format. So that can also be done. So I think this was helpful, and I wish, if there are any questions regarding how you can read the GRO files, then please let me know. So thank you so much.